Lesson 6.4, Logarithmic Properties. We have three properties of logarithms, and they're all based on the properties of exponents, because remember, logarithms equal exponents. So we have the product property. Remember, when we multiplied with the same base, you added the exponents. Since logarithms are exponents, if we multiply, we add the exponents. Logarithms happen to be exponents. Quotient property. Remember, if we divide with the same base, you subtract the exponents. So here, if we're dividing, we'll end up subtracting the logarithms. And remember, the logarithms are exponents. And lastly, the power property. So this is the one where if you have exponent, parenthesis, exponent, you end up multiplying the exponents. Well, that's what we do here. As far as this goes, if we have an exponent inside the logarithm, it can come in front, so that we have exponent, the n, multiplied by the other exponent, the logarithm. So it's when we have an exponent with an exponent, you can multiply the exponents. If you have an exponent inside a logarithm, it can come out to the front times the logarithm. So we can use these properties to expand and condense logarithms. So we'll start with expanding, which means you're going to take a single logarithm and we're going to rewrite it as several logarithms. For example, we'll try page 327, number 13. All right, looking at this, in general, when we expand, we're going to do the product and the quotient properties first, and then we'll do the power property. So looking here, I see it's 10 times x to the fifth. So the exponent of 5 is only on the x, not the 10. So I can't bring it in front of the whole thing because it can't be times the log 10 because 10 doesn't have the exponent. So we need to split this up. Since it's multiplied, we can rewrite it as addition. So we can end up rewriting it as two separate logarithms that we add. Now we have the exponent, which can go in front. So this was the first time was the product property. This was the power property. And then we can look and see to simplify. Usually we're done here. However, what's the base of this logarithm? You don't see one. So what is it if you don't see one? That's right. It's a 10. So I have log base 10 of 10. So what exponent of my base 10 gives me 10? That's right, 1. Log base 10 of 10 is 1 because the exponent on the 10 is 1. Why don't you try number 15? Pause it while you do the problem. The answer should be natural log x minus natural log 3 minus natural log y. All right, the other thing we can do is we can condense logarithms, which is the opposite of expand. So we're going to try to take several logarithms and rewrite it as a single logarithm. For example, page 327, number 25. All right, the first thing I notice is this number in front. Since it's multiplied by a logarithm, it can be written as the exponent using the power property. And then I see that we have a plus. So for adding logarithms, that was the same thing as multiplying. So you end up adding the exponents when you multiply. So we're going to multiply the things inside the logarithms. We'll multiply the 4 and the x to the 1/3. That's the product property. And that's pretty good, except for I notice the exponent here is a fraction. And often we don't like to write those as fractions. So we can rewrite it as, remember, you could rewrite it as a radical. The denominator of the radical is the index. You might want parentheses there to indicate that it's all part of the logarithm. Why don't you try number 23? Pause while you do the problem. Your answer should be the natural log of x to the 6th, y to the 4th. The other thing we're learning today is the change of base formula. And this shows why the calculators only have the 2 log buttons. Because really, you actually only need 1 logarithm button. Because we can actually change the base. Log base c of u equals log base b of u over log base b of c. And this lets you evaluate any logarithm on a calculator because this b, that's not over in this first part. So the b could be anything. So we let the b be 10 or e, so you can use our calculator. So essentially, to use our calculator for any logarithm, it's log of the big number divided by log of the base. For example, let's try page 327, number 31. Evaluate log base 9 of 15. So we could make that, well, we could use base 10. So it would be log of 15 over log of the base, and our base was 9. And so we could put that in our calculator. So we have log of 15 divided by log of 9. And you can see I get 1.232. Why don't you try number 29 on your calculator? Evaluate log base 4 of 7. Pause while you do it. Your answer should be 1.404.